In this video, we will see how we can plot graphs in real time and how we can use an board in an application. First of all, let's take a look at the hardware that we will use. We will use an Arduino board and a voltage divider circuit. We will use a flexi-force as our variable resistor. It is a force sensor which resistor changes when a force is applied. So to change the value of the resistor, the only thing we will need to do is to press on the sensor. We will read the voltage by using the A0 pin of the Arduino board. Now, let's dive into MatLab Appdesigner. The only component we will use is an axis component. For this application, we will just use a startup function. The first thing we need to do is to create an Arduino object. To do so, we will type A equals Arduino. Now we will create several variables that we will later use for configuring the axis on our graph. One will represent the range of time we want to display. We will also create two variables that represents the upper and lower bounds of the voltage. Now we create two vectors that will later contain the values of the voltage read and of the current time. We will also need a counter. Now we can start the stopwatch timer by using the tick function. Now we will create an infinite while loop where we will read the voltage from the Arduino and plot the value. The first thing we want to do in this loop is reading the voltage from the Arduino and store that value in our vector. To read the voltage from an Arduino board, we need to type the name of our Arduino object, read voltage, then we use the name of the pin on which we want to read the voltage. Then we want to store the current time. To get the time from the stopwatch timer, we type TOC. Now we update the counter. We will use an if loop to create the bound of the time axis. If the experiment has been running for less long than the range of time we want to display, we set up the minimum at 0 and the maximum at the range of time we want to display. Otherwise, we will set up the maximum at the current time, and we will set up the minimum in order to have the same range of time displayed. Now we will plot our results. First of all, we set the grid on. Then we plot the voltage and the time on our component. Finally, we configure the axis using the variables we created before. Now let's run the application. The voltage is displayed. And we can see that if I press on the flexi-force, the value of the voltage read changes. We can see that if our recording is longer than the range of time we want to display, our graph moves. Our application is working, however we must be aware that the two vectors that contains the current time and the voltage read grow each time we read a new value. Here is another program that solves this issue. The first lines are the same than our previous program. The main changes are to be found in the while loop. While the current time is lower than the range of time we want to display, we read the voltage and the time and stored them in the vectors as we did before. But if the current time is higher than the range of time we want to display, we create a for loop. In this loop, we will erase the values that are no longer displayed on the axis component. This way we free a space in the vectors to store the new value. This way the vectors don't get bigger each time we read a new value anymore. Then we can read a new value and store it in the brand new spot in the vector. Then we can plot on our component just as we did before. Let's run the function. Our application is working as well as